All right, working out these fission and fusion equations is a matter of understanding that the sum of the mass numbers and the sum of the atomic numbers has to be the same on both sides of the arrow. What we're going to do is we're going to start with the side that's complete. Notice we're missing a substance here. This is what we're going to be trying to find, that missing part. If we're going to find that missing part, we're going to start with the side that is complete. We're going to start over here with the uranium-235 and the neutron, 10N being the abbreviation for neutron. What we're going to do is we're going to add our masses together. We get a total mass of 236 over here, 235 plus 1. Then we're going to add our atomic numbers together. It's a total of 92. 92 plus 0 gives us a total of 92. We know, based on this, that the sum of the mass over here on the product side has to also be 236. So what we're going to do is just some simple subtraction to find what the missing mass is. We'll take 236, the mass from the product side, minus 144 from the xenon, minus 2 from the neutrons. 2 times 1 gives us that 2 that we're going to subtract there. So 236 minus 144 minus 2 is 90. The missing mass, the mass of our unknown substance, has to be 90 in order to keep the mass the same on both sides. We'll do the same thing with the atomic number. We'll start with 92, the mass from the starting side. Subtract out the 54 from the xenon, and 0, 2 times 0 for the neutrons. So 92 minus 54 minus 0 is 38. That's the atomic number of our missing substance. As always, we look up the symbol based on the atomic number. We look up the symbol based on the 38. Number 38 on the periodic table is strontium, Sr. We're going to do the similar kind of process with every kind of problem. We're going to look at what the total mass is on the complete side, subtract out what we have on the incomplete side to find the missing part. This third one is set up a little differently because we know the two product atoms that are going to be produced by the fission of uranium. What we don't know is how many neutrons. We know there's a 10N that belongs here. We know there's neutrons being produced. We just don't know how many. We have to find this coefficient that goes out front. And we're going to do it the same way we did the first one. We're going to total up what we have over here on the starting side. It's 236 for our mass. We're not really concerned about atomic number this time. We have a total of 92 over here. We already have a total of 92 over on our product side. So all we're concerned with is really the mass. We have 236. We need 236 on this side. So we'll take the 236 minus 96 minus 137. The 96 from the first element, the 137 from the second one. So we subtract that out. We get 6. Again, 236 minus 96 minus 137. I knew I punched that in wrong. Let's get 3. 3 is the number of neutrons that have to be produced in this fission reaction. Even if we're working back over towards the starting side, same principle. We're going to add together everything we have on our complete side. This time we're going to add together everything we have over here on the right. So we have 137 plus 97 plus 2. Again, 2 times 1. This is 236. 52 plus 40 plus 0 is 92. And subtract out as we go the other way. So 236 minus 1, 235. 92 minus 0, 92. Look up 92 on the periodic table. That's uranium. Those are the fission equations. The fusion equations are going to be solved using the exact same principles. We know that the total of the mass on one side has to be the same as the mass on the other. the total of atomic number on one side has to be the same as the atomic number on the other. So again, add up your complete side. 2 plus 2 is 4. 1 plus 1 is 2. Subtract out what you have on the other side. So we're going to do 4 minus 3. We have a mass of 1 left on that second part. 2 minus 2 is 0. The only thing we have with a mass of 1 and an atomic number of 0 is the neutron to put there. This is producing a neutron. And it would work the same way if we're going backwards. 4 plus 1 is 5. This is our completed side, so that's what we're going to work on. 4 plus 1 is 5. And then 2 plus 0 is 2. Again, subtract out what we have over here. 5 minus 3 is 2. 2 minus 1 is 1. Look it up by the bottom number. Atomic number 1 is hydrogen. So again, same principle. The sum of the mass on one side has to equal the sum on the other. The sum of the atomic number on one side has to equal the sum on the other. Add up your complete side first, whichever one you're not missing anything on. Add that side up first, and then subtract out what you have on the other side to find your missing part.